Okay, in hi, Bismillahirrahmanirrahim. In this lecture, we will start with little revision from the concept of differential. As we already studied, differentials or derivative tell us the information at an instant. So in mathematical notion, we are representing the derivative of y with respect to x in this formation, or of course, as we know that y is a function of x, so this can be expressed as f prime, and this differential further can help out to understand the concept of antiderivative or integral. So let me explain this Leibniz, this ratio. Basically these are the small ratio of the small chunk or small piece or small sample interval of y-axis with respect to x-axis, or you can say it's kind of a slope of y with respect to x-axis. In a graphical notion, we can see that if we have some path, for example, if on x-axis is the x value, and if this we are starting some of positioning, or you can say that movement from this point x towards some another point, there is change will happen, and till this final point we can say that it's the change. So total change from this position to this position can be represented with delta x along y-axis. Okay, this is along x-axis. Along y-axis, we can see that this position, okay, let me change the color, this position of y is, okay, suppose this one is the original position of y. Of course, this position, sorry, let me erase this. This is the initial value on, okay, y-axis, and this is the final value, okay, on this one, on the curve. So you can say delta y, or y approach the change, net change along y-axis will become delta y. So in this graphical notion, we can also say that from this point to y to this point is the delta y. If we apply limit, or limit in a sense that we want to check out the information at this piece where delta x, okay, big change, delta x approaches to become 0, definitely this delta x will become small increment along x-axis, or small sample interval along x-axis. This is the dx, small incremental, small increment. And if we proceed this line to the y-axis, so this point, so this small point very small point. See, along the once the small increment along the delta x, this delta v transformed in delta v also approaches to 0, so and becomes dy. Against small increment of x-axis, there is a small increment of y-axis. So ratio, you can say that ratio of a slope, rise our run, that is the y big ratio delta y over delta x on applying limit will becomes dy over dx. So further we can say that delta x transformed to the big change transformed to the small change along x-axis. Similarly, big change along y-axis transformed to the small change along y-axis. To explain this, we have one example. For example, we need to solve out 64.1 power 1 over 3. We need to find what is the value of y, or you can say we need to know the output. This is some kind of a simple mathematical expression, but in real life things are complicated with small increment changes. For example, if we see x can be a 64, but small increment here you can say is the dx, and if we are talking about dx, the total change, okay, on assumption basis we are saying that x is the 64. If the complete expression for this value can be written as 64.1, then in this complete expression the value, if we assumed x equal to 64, then dx will become 64.1 minus this, okay, x will go on the right hand side, it will become positive sign, will become negative sign, or cancelled out. So we will have 64, or you can say that dx small increment will happen in form of 0.1. So dx is calculated on assumption basis once we are considering x equal to 64, and we know this is the sum of, you can say that, big value along with small incremental values. Big value is, you can say, 64, and small increment in this big value is a dx. So it's the we calculated it 0.1. Okay, let's keep move on further. Suppose we have y on assumption basis as x equal to 64. So according to the given expression, okay, according to this expression, we are solving it with the help of differential. Instead of 64.1, we are considering it's the x equal to 64. So x 1 over 3, or you can say that we assumed (64). So in case of, okay, we are changing here the derivative variable x 1 over 3. So y differentiate with respect to x, we will have dy over dx. We will get 1 over 3 x minus 2 over 3. And what else? We will if we want to determine further by considering this ratio of dx by cross multiplying, we will have dy 1 over 3 x minus 2 over 3 dx. Now this, what we want to do, we want to determine the value of small change in y. Small change in y, we want to determine this value, and with the assumption big value is 64, and we know the dx from this equation. Okay, dx is equal to 0.1, big value is a 64. So by substituting this value, we can determine the answer of small increment along y-axis 1 over 3, and here 64 minus 2 over 3, and dx is what? 0.1. On further calculation, we will observe the value of dy equal to 1 over 40. 1 over 480. On further simplification, we will get this answer. So this is our dy. Now go back to the original question, this one, because we want to know the value of y. So it means this y is basically the composition of small increment of y-axis. Here we can notice this is the small increment of x-axis in terms of dx. So this y should be equal. Okay, let me write in the. So if we have 64.1 1 over 3, we supposed this x equal to 64. We calculated dx equal to 0.1. Then of course we will write an expression y plus small increment along y-axis. So here, by substituting the value of dy, we can determine the value of y easily. We can determine the value of y, because we know the value of dy is 1 over 480. So you can do it by yourself by considering all the known values in the above equation. You can determine the value of y. Thank you. The main theme in this example follows the principle of function of a slope, and this function of a slope, you can say in this example, one very important thing is this, that all the mechanism follow the concept of slope, and we know the formula for slope, that you can say that it is equivalent to the f(x minus a) minus f of x in the denominator is equivalent to x minus a. So we can write y to that f of x is a function of y, and the original value of y, some constant thing. So similarly in the denominator along x-axis, x2 minus x1, this is the slope. So by cross multiplying we will have x minus a, f prime of a, f of x minus f of a. We further can conclude it, the value of f of x by considering by adding both sides plus f of a. So we will get the value of f of x. F of x equivalent to f of a plus x minus a f of x. We can write f of x equal to f of a minus f prime of a to x minus a. We reduce this result from this, okay, by considering it on the opposite side. So this expression just I arranged f prime at first place. So we will have this result. Now it's very simple. See, if we have a equal to 64 such that f of a equal to f of 64, and we know in our previous example y equal to f of x, or you can say that f of a, or and further is 1 over 3. So here a is what? 64. So we can write 64 power 1 over 3. So it can be further, we can reduce a result in form of 4. F of a equal to 4. So, and similarly for f prime of x, we will have 1 over 3 x minus 2 over 3. By substituting the x equal to a, 1 over 3 a minus 2 over 3, by substituting the value of x so in this case f of a equal to 4. As we know, we supposed y equal to x 1 over 3 and x is 64. In that situation, y equal to 64, 1 over 3 becomes 4. Therefore, y plus dy, by substituting the value of 4 plus 1 over 480, will give us a result in case of same, okay. So will equivalent to the result of 64.1/3. All are same. So we concluded in this formation that in this example we deduce what's the value of small increment in terms of y-axis and what's the value of small increment in terms of x-axis. Thank you. Basically both are same. This same result. So this one is the in split form, this one is the combined form. So we can reduce the value of y once we can know the value of x, small increment of dx, small increment of dy. Very simple.